Hello students, in last lecture we discussed the mesh analysis and nodal analysis. Today in this lecture we will discuss the super mesh. Clear? It is just different from the mesh analysis because in this we will see there is a current source which is common to the two meshes, and the mesh analysis cannot be directly applied in this type of network. For example, this is the a network. Here this is the E1, this is the R1, this is R2, and this is E2. And say, if we see this is the I1 and this is the I2, now we have to calculate I1 and I2. We will see if this is the mesh 1 and this is the mesh 2, if you apply the KVL, then you will find in this drop, here is the voltage, but here we are connecting a current source which is common to the both mesh 1 and mesh 2. Clear? That means in this we cannot apply the KVL directly. Now in this type of questions we say this is the super mesh formation. Clear? Here the super mesh, it will be like this. You will see this is the super mesh. Clear? In super mesh we apply the KVL, then at a point which is the common to the mesh 1 and mesh 2 where the current source is connected, we apply the KCL. Clear? That means what is this? This is the super mesh. Any doubt? Clear? Now in this super mesh we will apply the KCL. Clear? Now you will see the mesh 1 I1, this is the I2. Now we write the KVL, write the KVL for the super mesh. KVL for the super mesh. Clear? That is I1 R1. Here the current is I1. Then what is the drop? That is the I1 R1. Clear? Plus now the drop in R2, that is the I2 into R2. I2 into R2, that is equal to the E1, negative to positive. It will be positive. This is the E1. Here the I2 is going from positive to negative. That will be the E1 minus E2. This is the first equation. Clear? Now you will see, if we apply here, that is, you will find that, say, this is the I. Clear? Now the incoming current is equal to the outgoing current. That means if at this point we apply the KVL. Clear? Now the KCL is applied at point X. Clear? You will see what is this? This is the I1. Clear? What is this? This is the I2. And what the KCL says? It says the incoming current is equal to the outgoing current. Clear? At the junction X, you will see what is the incoming current? I1 and this I, that is the I1 plus I, and what is the outgoing? That is the I2. Clear? Now this is the equation number 1, this is the equation number 2, and after solving the 1 and 2, we will get the value of the I1 and I2. Clear? So ये क्या चीज है? It is called the super mesh. Clear? Because we cannot apply directly the KVL in the mesh 1 and the mesh 2. Clear? Now we will solve with the examples and we can clearly understand how to apply the super mesh. Start. Now we will see. We are giving the values to the R1, R2, E1, E2 and I. Say R1 is equal to 1 ohm, R2 is equal to 1 ohm, E2 is equal to 2 volt, E1 is equal to 4 volt, and the current source having the current of 2 ampere in upward direction. Clear? Now you will see in this this is the common current source in the mesh 1 and mesh 2. Clear? That means what will be this? This is the super mesh. Clear? Now we will write the voltage equation or the KVL applying KVL in super mesh. In super mesh, say this is the A, this is the B, this is the C, and this is the D. So super mesh A, B, C, D, A. Clear? Now you will see I1 into R1, that is the I1 into 1 plus I2 into 1, that is equal to, here the current is I1 is going from negative to positive, that is the 4 plus 4, and here positive to negative, that is the 4 minus 2, or you can say I1 plus I2, that is equal to 2. This is the equation number 1. Clear? Now we will apply the KCL at X. Clear? Now the KCL, applying KCL at X. Clear? Then what is this? Incoming current is equal to outgoing current. What is the incoming current? I1 and 2, that is the I1 plus 2, that is equal to the I2. I1 plus 2, that is equal to I2, or you can say I1 minus I2, that is equal to the minus 2. This is the equation number 2. Clear? Now we will solve the I1 and I2. We will solve these two equations for I1 and I2. Clear? Now if we add this equation, that is the 2I1, that is equal to 0, that is the I1 is equal to 0, and what is the value of the I2? That is equal to the 2 ampere. Clear? And this is the solution for the super mesh. Clear? It is the clear, that is the super mesh. सबसे पहले क्या करा आपने? सुपर मैश देखेंगे कि सुपर मैश किस किस से ये कॉमन करके बनता है. कुछ और एक नेक्स्ट एग्जांपल लेते हैं, उससे थोड़ा आपको और क्लियर समझ में आएगा. क्लियर? स्टार्ट. Now we will see another example of the super mesh. It is the more complicated circuit with respect of the last example. Clear? You will see here the three meshes, mesh 1, mesh 2 and mesh 3. Clear? We have to find the current in 6 ohm using mesh analysis. Because we are applying the super mesh, I write down this is the super mesh. Clear? This is the mesh 1, this is the mesh 2 and this is the mesh 3. Let the current, mesh current I1, for 2 current is I2, and for 3, for mesh 3 it is I3. Clear? You will see, if you observe the mesh 1 and mesh 2, in mesh 1 and mesh 2 there is a current source. Clear? That means what will happen? It will be a super mesh. Clear? What is this? This is the super mesh, and we write down this is the A, this is the B, this is the C, and this is the D. Clear? So you will see, we will write down the equation or apply the KVL first of all for the mesh 3. Clear? Now the applying KVL in mesh 3. Clear? Then what will say? Where drop in the 6 ohm, that is the 6I3. Clear? Then drop in 2 ohm resistance, I3 इस तरफ है, I3 इधर जा रहा है बेटे, और I2 इस तरफ जा रहा है. Then what will happen? That will be the 2 into I3 minus I2. Clear? Plus the drop in 3 ohm, that is the 3 into I3 minus I1, and it will be 0 because in mesh 3 there is no voltage source. Clear? After solving this 6I3 plus 2I3 minus I2 plus 3I3 minus I1, when we will simplify this, you will get it is the equation 1 minus 3i1 minus 2i2 plus 9i3 that is equal to 0. Clear? Now we will apply KVL in super mesh. And what is the name of the super mesh? A, B, C, D, A. Clear? That is the A, B, C, D, A. Clear? Now you will see what is the drop in 3 ohm. That is the 3 into I1 minus I3. Clear? Because for the mesh 1, the dominating current is I1. That is the I1 minus I3. Clear? It is clear? When we write the mesh 3 equation, we write the drop in 3 ohm I3 minus I1 because in mesh 3 the dominating current is I3. Clear? Here the dominating current is I1. That's why we are writing the 3 I1 minus I3. Similarly, drop in 2 ohm resistance, the 2 dominating current for the mesh 2, that is the I2, that is the 2 I2 minus I3 plus 4 I2 plus 5 I1, that is equal to the negative to positive. That means this is the 20. Clear? Here the current is going from positive to negative, 20 minus 40. Clear? When you solve this equation, you will get the 8 I1 plus 6 I2 minus 5 I3 is equal to minus 20. Clear? Now we will apply the KCL. Clear? You will see this is the 1 ampere. I1, it is the incoming. I2, it is the outgoing. Then what is the incoming current? Clear? Say this is the point X. Now apply KCL at X. Clear? Incoming current. What is the incoming current? Clear? That is the I1 plus 1, that is equal to the I2. Clear? That means you are getting this third equation. Clear? After solving the 1, 2 and 3, you will get the value of I1 minus 1.346 ampere, I2 minus 2.346 ampere, I3 that is equal to minus 0.97 ampere. Clear? What is the requirement of our? That is we have to find the current in 6 ohm resistance. Clear? That means the current in 6 ohm resistance is I3. Clear? Here the I3 is flowing. Say this is the capital A and this is the capital B. Clear? The current is going from A to B. Clear? But here the sign is negative. That means the current is flowing from B to A. Clear? It is the another important example of the super mesh analysis. Now we will further go to the next example. Please see. It is clear? It is clear? Yes. Yes. Now we will discuss another example where we are using the 4 meshes. In first example, we use the 2 meshes. There are the 2 unknown, I1 and I2. In example 2, we use the 3 meshes and the unknown were I1, I2 and I3. Here we are taking an example of the 4 meshes. Clear? Here we have to find the current in I in 4 ohm resistance, current in 4 ohm resistance, and we have to find the power delivered by 12 volt source. By 12 volt source. Clear? You will see. Here the 4 meshes. 1, 2, 3, 4. The current source is connected in between the 3 and 4. That means this mesh, it will be the super mesh. Clear? You know that? What is this? This is the super mesh. Again we say this is the A, this is the B, this is the C, this is the D, A. Clear? That means the super mesh, it will be the A, B, C, D, A. Clear? First of all, we will write the mesh equation for the mesh 1. Clear? Apply KVL. Apply KVL for mesh 1. Clear? You will see what is the drop? That is the 6 I1. Here the current is minus I3. Clear? That is the 6. Clear? Into I1 minus I3. I1 is downward, I3 is upward. Then what is the resulting current? That is the I1 minus I3 plus 7 I1. And what is the value of the voltage? Plus 12, because the current is going from negative to positive. That is the 12. Clear? You will see 6 and 7, that is the 13, minus 6 I3. That means the equation 1, that will be the 13 I1 minus 6 I3, that is equal to 12. Clear? Now we will apply the KVL for the mesh 3. Apply KVL for mesh 2. Clear? What will be the equation? Here the current is I2, then drop will be 3 I2. Drop will be 3 I2 plus, here the drop will be 2 I2 plus 2 I2. Clear? Then what will be the current flowing in the 4 ohm? I2 minus I3. Clear? That is the 4 into I2 minus I3, that is equal to 6, because the current is flowing from negative to positive. Clear? Now you will see 3 I2 plus 2 I2, 5 I2 plus 4 I2, 9 I2. Clear? Minus 4 I3 is equal to 6. This is the equation number 2. Clear? Now we will apply KVL for super mesh A, B, C, D, A. Clear? The super mesh which is A, B, C, D, A. Clear? Now you will write what is the drop in the 4 ohm. Clear? That is the 4 into. Clear? Here the current is I3 minus I2. I3 minus I2. Clear? Plus 1 into. What is the current is? I4. So that is the I4. Clear? So 1 into I4. What is the drop in the 5 ohm? That is the 5 I3 plus 5 I3. And what is the drop in the 6 ohm? That is the plus 6 I3 minus I1. Clear? Now you will see the voltage sources. Here the current is coming from negative to positive, that is equal to the 6. Clear? After solving this, you will get the value of minus 6 I1 minus 4 I2 plus 15 I3 plus I4 is equal to 6. This is the 3. Clear? Now we will apply the KCL at this point. Clear? What is the incoming current? This is the I3. I3 is incoming. I3 is incoming. 8 outgoing. And here this is the I4. Clear? Incoming current. Then we will apply, say this point is X. Apply KCL at X. Incoming current is equal to the outgoing current. What is the incoming current? I3. Then I3, that is equal to the I4 plus 8. Clear? And this is the equation number 4. Clear? After solving the equation number 1, 2, 3, 4, you will get the value of the I1 1.818 ampere, I2 1.528 ampere, I3 1.939 ampere, and the I4 minus 6.061 ampere. Clear? We have to find the current in 4 ohm resistance. Clear? Then what is the current in 4 ohm resistance? That is the I2 minus I3. Clear? The current in 4 ohm resistance will be I2 minus I3 and you are getting the value. Clear? Now you will see power delivered by the 12 volt source. If we find the current through this voltage source, then what is the power? It will be the voltage into current. Clear? Then what is the power delivered by the 12 volt? That will be the P is equal to the 12. And what is the current passing through 12 volt? I1. So what is the value of the I1? 1.818. 12 into 1.818 watt. Then you are getting the value of the power delivered by 12 volt source. Clear? So this is the example of the 4 meshes. Okay students, today we discuss the super mesh, in which we take the example of the 1 mesh, 2 mesh, 3 mesh and 4 mesh. Clear? Now we will take the super node in the next lecture. Okay? If you have any doubt or any query, you can write in the comment box or email to me. Thank you.